Here we are given a rectangle ABCD with sides of the measure 6 centimeter and 8 centimeter. Then how much will the diagonal be? What will be the measure of the diagonal? We know that all four angles are 90 degrees. So we can apply the Pythagoras theorem and we can find that AC is what? It is 10 centimeters. But then sorry to break your heart, that is not the question. If only life was that easy. What the question is, let us find out. This diagonal AC is being extended to a point E such that AC is to CE is 2 is to 1. That means if this much is 2x, if AC is 2x, then CE is just x. What we need to find is the measure of this segment here. This DE is what we need to find. Now, what if we extend this BC to a point, say, P? Whenever we do this extensions, remember the property of being parallel or perpendicular. That also works for this extension. If two sides or two lines are parallel to one another, remember when you extend it, this bit will also be parallel to this line here. This bit CP will also be parallel to AD. The property of being parallel also gets extended. Now consider this beautiful triangle here. What triangle are we considering? ADE. Consider this triangle. In the middle you have a line segment CP. What is special about CP? AD and CP are parallel to one another. Now, if you first apply the BPT, what do you get here? This splits it in the ratio 2 is to 1. That means here also it will split it in the same ratio 2 is to 1, but for a different value. I will just take y. Here also it will split it in the same ratio, but the values will be different. No, here also 2 is to 1. Here also you will get a 2 is to 1. What we need to find is the value of this 3y. Now consider these two triangles here, the big triangle AED and the small triangle CEP here. It will be very easy to prove that they are similar. Why is that? To start with, you will have a common angle E and these two angles, these two lines are similar, right? So these two angles, the alternate interior angles will be similar. So using the AAA criterion for similarity, it is very easy to prove that these two triangles are similar. But when it comes to writing the name, please be very careful. The original triangle, the bigger one, I will name it AED, and where you see A, write C. Make sure that the equal angles come in the corresponding places. Don't change the order, otherwise the ratio of the sides will be all over the place. So please make sure you write the equal angles in the corresponding place. Where you see A, write C. Where you see D, write P. And E, of course, is the same. So this is how your similar triangles look like. Now if two triangles are similar, then the ratio of their corresponding sides are equal to one another. So you get such three equal ratios. Now do we know the value of any one of these ratios? Look carefully and tell me, do we have any information about any of these three ratios? What about this one? CE by AE, yes, we have information about it. CE is just x. AE is what? 3x. That means all of these three ratios are equal to what? 1 by 3. All of them are equal to 1 by 3. Then what? Can we get any more information from this set of equalities? Is it possible? Look at this AD. AD here is 6. That means what? CP is then what? You have CP is equal to 2. So we have found out that this extension, the one which we constructed, this extension is 2 units. Now what have we found out so far? We found out that the extension that we constructed is just 2 units. And what else did we find out? If DP is 2y, then PE is just a y. We found out that also. All we need to find is the value of this y here. Now consider the triangle DCP. What do you see here? The original figure that we started with ABCD is a rectangle, which means all 4 angles are 90 degrees. And 90 degrees here means what? This side will also be a 90 degrees. So DCP is a right angled at the vertex C, which means the hypotenuse is DP. So applying the Pythagoras theorem, what do we get? We found out that this is 2 and opposite side. In rectangle, the opposite sides are equal. So here we have an 8. So one side is 8, the other side is 2. Applying the Pythagoras theorem, you get what? You get DP is 2 root 17, which means what? We found out that it is 2y, right? We found out, we named DP to be 2y, which means what? Y is root 17. But then DE is equal to what? It is 3 root 17. The whole of BE is what? 2y plus y, which is 3y, or in other words, it is 3 root 17. And that is the answer that we were looking for. So that is all for today. Assalamu alaikum.